All right, so chapter 3 is going to be about data types. It's called Computing with Numbers, page 55. Do you understand the fundamental principles of how numbers are represented in a computer? Python math library, accumulator program pattern, and to be able to read and write programs that process numerical data. So the first thing I want to do in terms of the body of this chapter is to do the change.py program, and let's go over it together. So here's change.py. Program. Just calculates. I'm a huge fan of just practicing, the value of some, just to get the typing down, patiently write stuff down also at times. Okay, so so there we go. Let's call this main. Where's our semicolon? Or colon, excuse me. This is going to be change counter. Please. So 9/4. Valid quarters. And now we're going to be dimes. It's going to be invalid put times. Let's see, nickels. It's going to be the same. And the pennies. Plus dimes. Plus nickels. So 5. And then plus pennies. And if we want to separate these, I think it's visually appealing. And that's going to be adding all this up. So that's our total. I'm going to print. Remember, our total's not printed, it's just calculated there. Then we're going to print at the very end. But a comma will give us a space anyway, so we don't need to add that space here, right? If it was a plus, then and we wanted a space, then instead of a comma, we could do that. But since it's going to be a comma, we don't need that space. So now, since it's a comma, we're golden with regards to conflating those. If it was a place, we'd have to. If it was a plus, we'd have to change that to string str parenthesis total. But that's not the case. Okay, so we're going to call main. All right. And that function call is going to be left justified. Let's save it. Change.py, see where we're at. Let's see. Oh, there it is. Change.py. So let's open. Let's go to change.py. All right, let's check it out. So those are all comments because they're in red in idle. All right, looks pretty good to me. Quotes, colors, parentheses. If there's a mistake that I usually make personally, it's usually going to be parentheses. Like I'll put 2 here and only 1 here. So a lot of times there's an error. Look at the ones you make most often. All right, so here we go. Let's run it. All right, so let's do 3/4, 3 dimes, 3 nickels, 3 pennies, 123. All right, so 75, 85, 95, 105 plus 15 is 120 plus 3 is 123. And I think I know why this 0.002. Why would that be? Well, let's check it out. Here's why. It's because it looks like it's it should be exact. It should be exact. Let's change this eval. I don't know if that's going to make a difference. Again, I'm still relatively, green. So let's try int. Let's see if that makes a difference. It should. I think even though that's in the book as eval, I think as far as just the math, it might make a big difference. 0.01, 0.05, 0.1, 0.25. Now, right now, we don't know enough to round off to the nearest hundredth to make it, actual money. But let's see how it works. All right, so let's do open. No. Let's go here. All right, let's go here. So out of that. 75. Let's open it. Change.py. It's in the Python folder. Okay, let's check it out. Okay, print change counter. Blank line. Each coin type. They're all ints. All right, I think it looks pretty good. Parentheses, parentheses. Spacing is good. I think we're okay. All right, let's do 3, 3, 3, and 3. Ooh, I keep getting this mistake. It's not really a mistake, but just not exact. Just rounds it off here. Well, that's not something that I think we should worry about on this one. I just definitely wanted to check it out. You know, it all depends on the professor in terms of the exact the exact output. We did have an exact output on page 56 here that they did once. So let's run this again. Let's run this again. It's 5346. Let's see how it looks. I like to use examples. Oh, this is exact. Interesting. That's really interesting. We won't worry about it right now. I think it's a little bit advanced from where we're, where we're at here with, this book. Yeah, this is page 56, chapter 3, computing with numbers. It's part of the body of chapter 3. So, but I really like to punch in these, examples. We can also just out of practice, try this stuff out on the next page. So that's class int. So we're checking the data type, and then type 3.14. That's a float class. Obviously, 3.0 is also a float class, right? And then my int equals -32, and then type. Now in Python 3, can we do this? We cannot. This is also a function. Type is also a function, so you have to have an argument that is passed through the function. Same thing with print. A lot of these, the keywords they're now functions. All right, so it's a class int, and also just as a good practice, I always use parentheses now, even in Python 2. It's like I think it's good to build a machine there. So let's do my float, right, and then type my float plus float. All right. And then we've sort of seen this before. 0 plus 4 is going to be a float as well. How about 3 point plus 4 float as well? So anything that is, but what's cool we learned is that you don't have to put in that 0, here. So obviously 3.0 plus 4.0 is obviously going to be a float. 7.0 as well. So that's kind of cool. I always like to, do more than just what's on the page, like 58 and 59. Looking at these numbers and stuff, and just messing around. 4 divided by 3, and then that just cuts, that truncates. So 4/3 is 1/1/3, and then 4//3 is 1/1/3, and then it cuts the 3, and then these numbers cheat left, so let's do -4 divided by 3, negative. Let's do -4//3. It's -2. So basically, the negative, if that that // which is considered integer division, if as opposed to float division, the 1/, the integer division, it actually, if it's in between two integer values, that double slash, the integer division, it always goes to the lower integer, so the one that's to the left of the number line, that's farther left on the number line. So here, instead of going to -1, even though it's closer to -1 than -2, we actually, that integer division moved us to -2. So that's what I look for, is like, patterns, and I know that, that's what I've been learning because patterns are helpful. But it's definitely endlessly interesting, and I definitely try to use different all the different operators. Like 10 mod 3. That's the remainder. 10 divided by 3. The remainder is going to be 1. And then if it's going to be 10 point mod 3, it's going to be 1.0, right? Yes. So it's pretty aggressive. Remember, the float division operator always returns a float. And then integer division obviously always produces an integer. And then check us out next time. We'll be using the math library from page 60 on chapter 3 in the body of the chapter. Thank you very much.